Good morning to everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, in the particular video, I'm going to explain about the WATM. That is nothing but a wireless ATM. That is wireless automatic teller machine. So this wireless ATM, sometimes also called as a wireless mobile ATM, a WMATM, which does not only describe a transmission technology but tries to specify a complete communication system. So, Akampara 1996 and Inoglu 1996. These are the various communication systems, wireless communication systems, which is used in the previous years. While many aspects of this IEEE WLANs originate from the data communication community, it has been developed in many areas. So the need for this seamless integration of wireless terminals into an ATM network. So this is a basic requirement for supporting the same integrated services and different types of traffic based ATM which does not used in the which does it in the fixed networks. So the main motivation of this WATM is this ATM networks scale well from LANs to WANs, that is local area network to wide area network, and the mobility is needed in local and wide area applications. The strategies were needed to extend this ATM for wireless access in local and the global environments. For ATM to be successful, it must offer a wireless extension. Otherwise, it cannot participate in the rapidly growing field of mobile communications. This WATM could offer quality of service for adequate support of multimedia data streams. Many other wireless technologies like IEEE 802.1, which typically uses only offer the best effort services or to some extent time-bound services. However, these services do not provide as many like a quality of services parameters as a ATM networks do. So for the telecommunication service providers, it appears natural that merging of mobile wireless communication and the ATM technology which leads to the wireless ATM. So the one goal in the context is the seamless integration of mobility from ISDN which already uses ATM as its transfer technology. So this WATM services are where it is used in office environments, universities, schools and the training centers, then industries, hospitals and in home and also in the network vehicles. So this is the generic WATM reference model where MATM is nothing but a mobile ATM terminal. From the terminal it is being given to the wireless ATM terminal adapter, then it is given to the RAS, then to the EMASE, then to the EMASN, then finally to the ATM switch, or it is being given to the fixed end system where the group of WATM terminal, MATM and RAS will be called as a radio segment. So EMAS, E and N, ATM switch and the fixed end system will be together called as a fixed network segment. So the mobile ATM terminal which uses a WATM terminal adapter to gain wireless access to a WATM radio access system. Then the MATM service terminal could be represented by will have an example of laptop which uses an ATM adapter for wired access plus software for mobility. So the WATM terminal adapter enables wireless access, that is it includes the transceiver etc. but it does not support mobility. RAS with the radio transceivers is connected to a mobility enhanced ATM switch which in turn connects to the ATM network with mobility aware switches and our switches, that is N and other standard ATM switches. Finally, a wired non-mobility aware ATM end system may be the communication partner. The various quality of service of a mobile are a wired, wireless and a handover. So wired quality of service is nothing but the infrastructure network here in this needs same properties as a wired ATM network. So the typical traditional QoS parameters are link delay, cell delay variation, bandwidth, and a cell error rate, etc. Then wireless QoS. So the main property of this is it differs from network to those of the wired part. Again, the link delay and error rate can be specified, but now error rate is typically some order of magnitude that is higher than, that is I will call an example of a fiber optics. So the channel reservation and multiplexing mechanisms at the air interface strongly influence cell delay variation. So the next one is handover QoS. Here the new parameter which is introduced is a handover. Handover blocking due to limited resources at target access points, where here the cell loses during the handover, or the speed of the whole handover procedure represents critical factors for this quality of service. So let's recap. ATM can be used for network coverage in any range, and here the price of this will be low. Thank you.